Download this code from codegive.com, link in the description below. Understanding and resolving Go cannot use base URL type url.url as type string. This error arises in Go when you're trying to use a variable of type url.url, from the net/url package, where a string is expected. It's a common issue, especially when dealing with URL manipulation, and understanding why it happens and how to fix it is crucial for building robust network-related applications in Go. Why the error occurs: type mismatch. Go is a statically typed language, meaning that the compiler enforces strict type checking. A url.url represents a parsed URL, broken down into its various components: scheme, host, path, etc. It's a struct containing information about the URL. A string, on the other hand, is simply a sequence of characters. The compiler sees them as fundamentally different types. The error message, "cannot use base URL, variable of type url.url, as type string in argument to function X," clearly indicates that you're passing a url.url value to a function or assigning it to a variable that expects a string. Common scenarios where this error happens: 1. Directly passing url.url to functions expecting strings. This is the most straightforward case. Many standard library functions and third-party libraries expect URL strings as input, not the url.url struct itself. Examples include *http.newRequest, the URL parameter must be a string. *os.openFile, when accessing remote files the URL parameter is a string. *log.printf, when logging a URL, it's often more readable to log the string representation. 2. String concatenation with url.url. Attempting to concatenate a url.url directly with a string using the plus operator will also result in this error. 3. Setting URL as a string in HTTP requests or other data structures expecting strings. HTTP headers, query parameters, and other data structures often require URL representations as strings. 4. Storing URL in string-typed fields. If your data model has string fields intended to hold URLs, you need to convert the url.url to a string before assigning it. How to fix it: converting url.url to string. The solution is to convert the url.url value to its string representation using the .string method. The url.url struct has a built-in string method that returns the complete URL as a string. Code example demonstrations and solutions. Let's illustrate with several code examples covering the common scenarios and demonstrate how to correctly use the .string method. Example 1, creating an HTTP request. Explanation: we parse a base URL using url.parse. The http.newRequest function expects a URL string as its second argument. We use base url.string to convert the url.url struct to its string representation before passing it to http.newRequest. This resolves the error. Example 2, appending a path to a URL and using it in a request. Explanation: we parse a base URL. We set the path field of the url.url struct to /API/v2/users. This correctly modifies the underlying URL object. To add another path/profile, we concatenated it with the string representation of the base URL. You must reparse to generate a valid URL object. We use the .string method again to get the full URL as a string before passing it to http.newRequest. Example 3, using query parameters. Explanation: we parse the base URL. Asterisk we use the query method to get a url.values object representing the query parameters. Asterisk we add new query parameters using add. Asterisk we encode the query parameters using encode, and set the raw query field of the url.url struct. This is important because raw query expects the encoded string. Asterisk we convert the modified base URL to a string using .string, before creating the HTTP request. Example 4, logging a URL. Explanation asterisk. Asterisk log.printf expects a format string and arguments. Using %v with a url.url might print the internal representation of the struct, which is often not what you want. Asterisk using %s with base url.string, provides the clean, readable URL string for logging. Best practices and considerations asterisk. 1. Parse URLs early asterisk parse the URL as soon as you receive it from an external source, example user input, configuration file, API response. This allows you to work with the structured url.url object and catch parsing errors upfront. 2. Use url.values for query parameters asterisk always use url.values and its methods, add, set, get, encode, to manipulate query parameters. This ensures proper encoding and avoids common pitfalls. 3. Immutable strings asterisk remember that strings in Go are immutable. When you need to modify a URL, it's generally better to work with the url.url object and modify its fields, example path, raw query, directly, rather than trying to build the URL string manually through string concatenation. 4. Error handling asterisk always check the error returned by url.parse. A malformed URL can cause unexpected behavior and potentially security vulnerabilities. 5. URL encoding asterisk be mindful of URL encoding when constructing URLs, especially when dealing with user-provided data. The url.queryEscape and url.queryUnescape functions can be helpful for encoding and decoding URL components. However, url.values.encode handles most encoding requirements automatically for query parameters. 6. Consider net/urls helper methods asterisk the net/url package provides helper methods for manipulating URLs. Familiarize yourself with functions like url.joinPath, Go 1.19+, for safely joining path segments. Prior to Go 1.19, you could achieve similar results with strings.join in conjunction with URL parsing and formatting. 7. Use path escape properly asterisk use url.pathEscape to correctly escape path components. Summary. The Go cannot use base URL type url.url as type string error highlights the importance of type safety in Go. The solution is consistently converting url.url values to strings using the .string method whenever a string representation is required, especially when passing URLs to functions, logging, or constructing HTTP requests. By following the best practices outlined above, you can effectively manage URLs in your Go applications and avoid common pitfalls. Always remember to parse early, handle errors, use url.values for query parameters, and leverage the net/url package's capabilities for robust URL manipulation.